Lesson 2.2, Identifying Functions. This part of the video will explain part 1 of lesson 2.2, mainly centering around what domain and range is, tables, and ordered pairs. So, as a review, we'll be going over some basic definitions related to this topic. So, a domain is a list of inputs. What is a list of inputs? That is basically the thing you're putting into your function to get your resultant output. So for example, let's say I'm using a certain amount of money, or maybe like this amount of money will get me this amount of cupcakes. So in this situation, my domain will be all the possible amount of money I can spend, and my range will be all the amount of corresponding cupcakes I can buy. So that is the input-output situation. So again, the range is the corresponding list of outputs to our domain, which is the list of inputs. So domain and range, they work closely together. Now, what is a function? A function can be defined in many ways, but one way to look at it is that each input, like the amount of money I can spend, leads to exactly one output, which is the amount of cupcakes I can yield. So essentially, you can think of functions as a tool to represent your domain and range at the same time. Now, one thing to be careful about is when you have a domain and a range, it doesn't mean it's always a function. It can also be a relation. Now, what makes a relation and a function different is that for functions, each input, again, can lead to only one output, but for relations, an input can lead to multiple outputs. So let's say my input, maybe x, is 1. In a function, 1 can only equal to something else. So maybe 1, after we do something to it, becomes 2. But in a relation, if I put 1 into my relation, maybe I can get 2, but then I can also get 3. So I'm getting more than one thing. I'm getting 2 different things here. That makes it no longer a function. That is now instead a relation. So let's put this into context so everything makes more sense. Now let's look at this tool to analyze functions. This is called a table. And in the context of analyzing functions, a table should be structured so that on the left side, if you look at this example here, you can see that the x is on the left and the corresponding y is on the right. Or the inputs are on the left and the outputs are on the right. Know that when we talk about functions, the most common letters or variables we use is x and y, x meaning inputs and y meaning outputs. Now let's put this into an example so everything makes more sense. So one example included on Apex is tree size. So let's use that. So for tree size, your input will be the amount of time that has passed. So maybe time in years. And your output will be the tree size after a certain amount of time. So you can see how this makes sense because as time passes, a thing or tree ages, and as a tree ages, it's probably gonna grow larger or smaller in size. It's probably not gonna stay static. But regardless, that's the situation we have here. So looking at a table here, the table we have here, you can see that our input in this case will be the amount of time that has passed in years. So we have 1 year passing, 2 year passing, 3 year passing, and 4 years passing. And the corresponding output, which is the size of a tree, let's just ignore the units for this. So maybe 0.5 for year 1 to 1.2 for year 2. Maybe I'm referring to height, perhaps in meters. And then maybe in year 3, you become like 2.1 meters tall, and so on and so forth. Now, a table is a good tool for us to understand functions enough so that we can represent it in the form of an expression. So basically using letters and symbols. So if you remember from the previous lecture, I can abbreviate the concepts I'm trying to communicate into a single letter. So since my input is time, and it starts with a T, I'm just going to call it T. So my input, I just call it T. And as for my output, the tree size, I can call it S, because size starts with the S. These are just arbitrary letters. You can call it A and B, C and D, but for convenience sake, I'm going to call my time T and my size S. So again, as my T, which is my time here, increases, you can see that the size of a tree also changes, which in this case is also increases. So with that knowledge, let's put that aside for a second and make sure that we understand what a function and relation is. So as we defined before, a function is when one input leads to exactly one output, and a relation is when one input leads to multiple outputs. So in the context of a table, you need to know that a table might not just represent a function. It can 100% also represent a relation. It is just essentially representing a list of inputs and a list of corresponding outputs. So looking at the first table I have here, is that going to be a function or a relation? Please take a second to pause the video and see if you can figure this out. All right, so looking at this list, I can see that there are 2 10s here, which I've circled. So as you can see, something is repeating here, but actually this is a function. Now, why is this a function? As we know, for a function, one input leads to one output. But there's no rule to say that the output has to be different. So here, all inputs, 1, 2, 3, 4, lead to their own outputs, and no input leads to more than one output. So that's good. Now, even though input 1 and input 2 both lead to the output of 10, that is totally fine in this situation, because the only thing that matters is that one input leads to one output. 2 inputs can totally lead to the same output. But as long as one input, or one x, doesn't lead to more than one y, then we're fine. This will make more sense as we try to graph these functions. Now, let's look at the second example. Is that going to be a function or relation? Take time to pause this video and try to figure this out on your own. So in this case, I can see that 2 is repeated twice on the input side. So the input of 2 essentially can lead to 11, but the input of 2 can also lead to 13. In this case, this is not a function, because one input, which is 2 in this case, leads to the output of 11, but it can also lead to the output of 13. So that is no longer a function, that is a relation. Now that we know what a function is, let's go back to the example of this tree size thing here below. So we were talking about how these we can use symbols and letters to represent these tables. So again, we abbreviate a time into T and a tree size into S. If I were to write this situation of my tree size over time as a function, I'll call it sometimes like this. There's different ways to express it, but this is the most typical way. So it's just S on the outside with a bracket of T. So what this means basically is that your size of the tree is a function of time. Now, what that means is that the size of a tree is basically based upon how much time has passed. So the amount of time that has passed is going to influence your tree size. So let's put some actual numbers into this function expression we have here so that you can have a better understanding of what this means. So again, S bracket T, N bracket, that basically means tree size over time. So for example, let's say I have S1 equals to 0.5. Take your time to pause this video and try to see what that means. Now, looking at this, I can see that my T is equal to 1. And my S bracket 1 is equal to 0.5. So we know that T is time and that S bracket T is tree size over time. So we can see that this basically means that in a span of T equals to 1, which is 1 year, a span of 1 year, the tree grew or increased in size by 0.5. So since T is your input, you can think about it like this. Your input causes the output. So your input causes the output to become this. That is a way to think about what these functions actually mean. Now, one last thing to learn in this part of lecture 2.2 is the definition of ordered pairs. So ordered pairs is just a pair of elements in a function. So any x paired with any y. And you write it like this. Bracket x, comma, y, and bracket. So to make this make more sense, let's go back to the tree size table example. An ordered pair, or ordered pairs here, is just basically your input and its corresponding output. So for example, one ordered pair I have here is, I can make it from this 1 and 0.5. Since x, which usually means input, is on the left, and y, which usually means output, is on the right, I can just write my first ordered pair, which I take from this tree example, as this. 1, comma 0.5. And my second one basically goes along the exact same idea. Sorry, that was a really ugly line. There we go. So this second order pair I have, again, with the input on the left and the output on the right, can be represented like this, and so on and so forth. Now we can use ordered pairs to help us illustrate a function in the form of a graph. We'll be going over this in the next video.